again. Happy to see you in our fourth session about fx-Calc, and our topic for today is sum and product calculation. That may sound a bit complicated, but it isn't at all. It's basically very much the same thing that you would do if you, for instance, implement a for loop in a programming language and would, for instance, sum up whatever kind of data in this for loop. And yeah, fx-Calc provides you two possible ways to handle this. One is, as mentioned, to sum up specific terms, and the second thing is to do the same thing, but not summing them up, but doing products. So by the nature of this functionality, it's maybe obvious that if you enter the specific term into this text box here, it will not be calculated immediately. So that's a difference to all the other calculations that you could perform here in this user interface. And for this reason, we have this run and stop button here exactly in the same area, because with the run button you can launch the calculation, the iteration if you want, and as we will see, there is a possibility to let this iteration going on forever, unlimited if you want, and to stop it at a certain point in time where you think the result has achieved a certain stable value or whatever. So it gives you really the possibility to observe a specific development or a specific result evolving by such a sum or product iteration. Well, before I talk longer about this, let's start with a quite interesting example. So I'm simply pressing this sum button here, and that's basically how it looks like. It starts with some parameters. So a sum is always running from a start parameter to an end parameter. In this case, it would start from 0 to 100. And this part here is really to specify the term which shall be used for summing up values. So maybe a quite well-known one is to sum up the numbers from 0 to 100, and I simply have to put n here, because the system knows automatically I have to sum up all numbers starting from 0 to 100, and that's it. And if I click on the run button, I get exactly the number which was also calculated and provided by the Gauss expression, which is 5050. Quite interesting. And another very specific capability of fx-Calc is that I can extend this specific calculation by another parameter. Let's call it x1. And I can put a value here for x1. Let's take 3 for instance. And I could sum up n times x1. This way. So well, we all know the result, which is 15,000 something. And if I click on the run button again, we see that it's making use of this parameter in this case. Okay, let's follow up with another example about sum calculation, and that's the one which would provide us a number of sticker cards that you need to buy in order to make sure you have at least one of each of those sticker cards in your collection. You may remember the folders, collection folders that you can buy and fill, and just to have one sticker of each in your collection, you need to buy a certain number of stickers, total number of stickers, to make sure that's being satisfied. So let's click again on the sum formula in this case, and usually you start with one sticker and you may need 640 stickers to have a complete collection, yeah, each sticker one time in your collection, then the formula to calculate this is the number of stickers divided by n, yeah, so like this. This provides you the number of stickers that you would have to buy. Yeah, and if you click at run in this case, we see that for a collection of 640 stickers, you need to buy a total of 4,505 stickers to get it completed at least. And that's still based on the assumption that all stickers are evenly distributed in all packages and yeah, in all stores where you can buy them. Yeah, so it's basically still quite optimistic, and but provides you an indication about what needs to be invested here. So maybe the better idea is really to look for examples to exchange cards with others, yeah, rather than go and buy all those sticker cards. The next thing that I'd like to show you about sum calculation is quite easy one. Let's focus again on summing up simply the number n, yeah. The thing I'd like to show you is really how this would work if you would set the second parameter to 0. Yeah, usually you would set here an end parameter, which says by example 100, where we would get to the 5,050 total. Yeah, but the other and interesting possibility of this calculator is to set this parameter to 0, and in this case it's not stopping the calculation. Yeah, so if you click on the run button, it goes and goes and goes forever if you want. Yeah, the advantage of this functionality is that you can observe how the result of this calculation is evolving. Yeah, and for instance, if we look at the p calculation, you will encounter that that's getting to a more or less stable value at a certain number of iterations. So, and that's then the point where you could stop the calculation, or if it's not getting to a point which would be interesting for you, you can stop it anyway by simply clicking the stop button. Yeah, if you click the stop button, this kind of endless sum calculation, sum iteration stops. And let's take the p calculation as another example for this. So that's the more, yeah, the more sophisticated one. Let's take the more easy one from Leibniz. Yeah, let's try this one here as well. Yeah, and see what we get. So you see that this one here isn't getting that much fast to the point as the other calculation would do. Yeah. So bottom line, you get to a p iteration to a certain extent. Yeah, but it's not as precise as the other would be, and it's still changing in the last digits area. Yeah. So that's another example of exactly this functionality, and we could stop it here at approximately 32,000 iterations. It's quite close to p at this number of iterations, but the advantage of the functionality is clear. I think you can really observe how the result of your calculation evolves. Yeah, so that's quite interesting for experimental topics, and yeah, I hope you will enjoy this functionality. Yeah, last but not least, a short word about products. Yeah, because at the end of the day, products are quite similar to some calculations. The only difference in syntax is that it starts with a P rather than an S. Yeah, and bottom line, there's only one thing that needs to be mentioned here. Yeah, if your calculation formula would lead to the point where one of the factors is getting to 0, then of course the complete result of your calculation is 0. Let's make a simple example here by saying just 1 to 100 for n. Let's get the result of this. As you can see, it's a quite huge number with 157 digits normally. And if we would change the first parameter to 0, yeah, of course the result is 0, yeah, simply because one of the factors in this calculation is 0. I hope you enjoyed our today's session about sum and product calculation, because it provides you powerful capabilities to perform experimental calculation. I hope to see you again in our next session, which will focus on graphical presentation of yeah, mathematical expressions. We talk here about 3D surfaces or 2D graphing, 2D plots of functions. Quite interesting, I hope. And yeah, see you next time. Take care. Bye bye.